Welcome friends. Let us continue to study heat engine on my YouTube channel. Kindly like, share and subscribe my YouTube channel. The topics included in today's lecture are construction and working of diesel cycle and efficiency of diesel cycle. Diesel cycle, which is the air standard cycle. This one is a cylinder, this one is a piston, and working medium, that is air is filled up inside the cylinder. Let us draw it on PV diagram. So it is the condition or state number 1 where the pressure is P1 and volume is V1, and it is that total volume of cylinder. So that is V1 is equals to Vt is equals to total volume of cylinder. Now piston moves from ODC to IDC, that is the right hand side to left hand side, and reaches to the IDC, that is the extreme left hand side, and it reaches to the point number 2. And at point number 2, pressure is P2 and volume is V2, and this one is the volume, and this is the volume or a gap between the piston and cylinder head when piston is at IDC, that is the inner dead center, and that volume is known as the clearance volume. So we can say that V2 is equals to Vc is equals to clearance volume, and process number 1, 2 is the isentropic compression process. Now heat is supplied to the working medium, and as the heat is supplied to the working medium, the piston moves right hand side somewhat. So that is the piston moves right hand side, keeping the pressure of air constant. So it is a constant pressure heat supply process. So 2 to 3 is the constant pressure heat supply process. So it is drawn horizontally on the PV diagram. So 2 to 3 and heat is supplied. And at point 3, pressure is same as P2 and volume is V3. Now the piston moves towards the right hand side, that is the outer dead center, and it is to the outer dead center, and that process is process number 3 to 4, and it is known as the isentropic expansion process. And at point 4, the pressure is P4 and volume is V4, and we know that at V4 pressure is equal volume is equals to V1, so it is V4 is equals to V1 is equals to Vt, that is equals to total volume of cylinder. And finally the heat is rejected from a working medium, but the volume of working medium does not change, and it follows the process 4 to 1, and that is known as the 4 to 1 constant volume heat rejection process, and due to that it is V1 is equals to V4. Now R, that is the compression ratio, Vt by Vc. Now Vt we know that it is V1 or V4 and Vc is V2. So we can write down R is equals to V1 by V2, that is equals to V4 by V2. So that is one ratio, compression ratio, that is equals to V1 by V2, or it is V4 by V2. Now another ratio we are going to define for the diesel cycle is the cutoff ratio, rho. Now cutoff ratio is equals to volume of air at the end of the heat supply divided by volume of air at the beginning of heat supply. Now you just see during which process heat supply takes place, 2 to 3. So at point 2 heat supply starts, at point 3 heat supply stops or ends. So volume of air at the end of heat supply, it is V3. So we can say it is V3. And volume of air at the beginning of heat supply. So at the beginning of the heat supply volume is V2. So the rho cutoff ratio is equals to V3 by V2. Now we are going to define the another ratio, that is V4 by V3. So V4 by V3 can be written as V1 by V3, because V4 is equals to V1. So it is V1 by V3. Now instead of V1 by V3 we can write down V1 divided by V2 multiplied by V2 by V3. So we have divided and multiplied by V2. So it is V1 by V2 multiplied by V2 by V3. So what is V1 by V2? V1 by V2 is R. So instead of V1 by V2 we can put the R. And what is V2 by V3? That is the reciprocal of the rho. So it is the R divided by rho. So it is V4 by V3 is equals to R divided by rho. So here we have derived three ratio: compression ratio, cutoff ratio, and another ratio, that is V4 by V3 is equals to R divided by rho. Now let us draw the TS diagram from the PV diagram for the air standard diesel cycle. 8.1 pressure is P1 and volume is V1, which is here 8.1, temperature is T1. It passes through the first process, 122 isentropic compression process. And as it is an isentropic, entropy remains constant. So it is a vertical line on TS diagram. And it reaches to the temperature T2. And here S1 is equals to S2 because entropy is constant. Next process is constant pressure heat supply process 223. And it is drawn by the curve on the TS diagram. So 223 is the constant pressure heat supplied, and 8.3 temperature is T3. Then the next process is 324, that is the isentropic expansion process. It means the entropy remains constant during 3 to 4. So it is vertical line 3 to 4, entropy remains constant, so it is S3 is equals to S4, and temperature at 0.4 is T4. And 4 to 1 is constant volume heat rejection. So here it can be shown by the curve 4 to 1, and heat is rejected by this process. So this is the TS diagram for the air standard diesel cycle. Now the air standard efficiency of diesel cycle. So first we will calculate heat supplied, heat rejected, then work done, and then efficiency. So first of all, heat supplied. Heat supply takes place during which process? Yes, it takes place during process number 2 to 3. And it is constant pressure process. So we have to write the equation for the constant process heat transferred equation here. And that is equals to M into Cp into delta T. Now what is delta T here? Between process 2 to 3, it is M Cp T3 minus T2. Now heat rejection. Heat rejection takes place during which process? 4 to 1. And what is the process? Process is the constant volume process. And the equation for heat transfer for constant volume process is mCv delta T. And what is delta T for the process 4 to 1? It is T4 minus T1. So we have got the equation for the Qs and Qr. Now work done. So work done is equals to Qs minus Qr. Now air standard efficiency. That is equals to work done upon heat supply. Now substituting the equation, Qs minus Qr divided by Qs, putting the values 1 minus Qr by Qs, and therefore it is 1 minus M into Cv into T4 minus T1 divided by M into Cp into T3 minus T2. Which term can be cancelled? Mass can be cancelled. So it is T4 minus T1 divided by taking Cv into the denominator. So it is Tp by Cv multiplied by T3 minus T2. What is this ratio? Cp by Cv, that is gamma. So we can say that it is 1 minus 1 upon gamma multiplied by T4 minus T1 divided by T3 minus T2. That is the equation of air standard efficiency of diesel cycle in terms of temperature. Now let us calculate the another equation for the air standard efficiency of diesel cycle by simplification. Now these are the ratios that already we have derived. R is equals to V1 by V2, that is equals to V4 by V2. Cutoff ratio rho is equals to V3 by V2, and V4 by V3 is equals to R divided by rho. Now let us select the process 1 to 2, isentropic compression process. And for that we can write down T2 by T1 is equals to V1 by V2 raised to gamma minus 1. What is V1 by V2? R. So that is R raised to gamma minus 1. So we can write down T2 is equals to T1 into R raised to gamma minus 1. Now let us take the another process. Process 2 to 3, constant pressure heat supply. Now what is the PVT relationship for the constant pressure heat supply? V by T is constant and it is for the process number 2 to 3. So we can write down V2 by T2 is equals to V3 by T3. So T3 is equals to T2 multiplied by V3 by V2. Now what is T2? T2 we have already derived. T1 into R raised to gamma minus 1. And what is V3 by V2? That is rho. So we can write down T3 is equals to T1 multiplied by R raised to gamma minus 1 into rho. Now next process, isentropic expansion, that is 3 to 4. T3 by T4 is equals to V4 by V3 raised to gamma minus 1. Now what is V4 by V3 ratio? We have already calculated. V4 by V3 is R divided by rho. So that is equals to R divided by rho raised to gamma minus 1. So we can write down R raised to gamma minus 1 divided by rho raised to gamma minus 1. So T4 is equals to T3 multiplied by rho raised to gamma minus 1 divided by R raised to gamma minus 1. Now putting the value of T3. Now what is T3? That we have already calculated. T1 into R raised to gamma minus 1 into rho. So that is equals to T1 into R raised to gamma minus 1 into rho multiplied by rho raised to gamma minus 1 divided by R raised to gamma minus 1. So what will be cancelled out? R raised to gamma minus 1 will be cancelled out. So it will be the T1 into rho raised to gamma minus 1. So again simplification, what we are going to get? T1 into rho raised to gamma. So that three equation we have got, T2, T3 and T4. Substituting all three values in the equation of the efficiency of diesel cycle. So 1 minus 1 upon gamma multiplied by, instead of T4 we have written the equation, T1 as it is. Instead of T3 we have written this equation, and instead of T2 we have written this equation. And what is common in the denominator? Let us take in the numerator. First we can take the common T1. So T1 into rho raised to gamma minus 1 and T1 into bracket R raised to gamma minus 1 into rho minus R raised to gamma minus 1. T1 cancel. So the answer is this. Now what we can take common in the denominator? That is R raised to gamma minus 1. So taking the common. 1 minus 1 upon gamma multiplied by rho raised to gamma minus 1 divided by R raised to gamma minus 1 multiplied by rho minus 1. That is the equation of air standard efficiency of diesel cycle. Now from this equation we can say that if rho is equals to 1, air standard efficiency of diesel is equals to this. And this is the equation of Otto cycle. Now from this equation we can also say that efficiency of diesel cycle depends on the value of R, rho and gamma. While gamma is constant, so it depends upon R and rho. R is the compression ratio and rho is the cutoff ratio. And as the compression ratio increases, efficiency of the diesel cycle increases, and as the cutoff ratio increases, efficiency of diesel cycle decreases. So this is the graph, shows the relationship between the diesel cycle efficiency and compression ratio for various value of rho. So if rho is 1, it is the Otto cycle. For rho 2, efficiency is less than Otto cycle, rho 3, rho 4. So you can see that as the compression ratio increases, efficiency of diesel cycle increases, but it is always less than the efficiency of Otto cycle. Kindly ask your queries in the comment box. Kindly like, share and subscribe my YouTube channel. Thank you.